Is humanity truly alone in the vast universe? Among billions of galaxies and countless exoplanets, that question remains one of science's greatest mysteries. But Professor Nikku Madhusudhan is better placed than most to answer that question. An astrophysicist at the University of Cambridge and a leading voice in exoplanet research, Madhusudhan made global headlines in 2025 using the powerful James Webb Space Telescope that has revolutionized astronomy. His team last year detected potential signs of life on K218b, a planet located 120 light years away. While the findings are groundbreaking and stirred up huge debate, months later the professor remains cautiously optimistic, placing about 95% confidence in the possibility of life in alien planets, while explaining what it will take to confirm it fully. During his recent visit to the International Center for Theoretical Sciences in Bengaluru and after a lecture at Pint of View, he spoke to the Federal about the significance of this discovery, the idea of Hycean worlds, and how new space technologies like the JWST are transforming our understanding of the universe as we know it. He also reflects on a deeper question: where does the idea of God fit within this vast cosmos? Here's Professor Nikku Madhusudhan in conversation with the Federal.
So what we have found recently with observations of this particular planet, K218b, are tentative signatures of absorption, excess absorption in its atmospheric spectrum of which we are thinking is from a molecule called dimethyl sulfide or dimethyl disulfide, both of which are known to be signatures of life here on Earth, are known to be biosignatures and produced primarily by life here on Earth. So we think that there is a possibility that this planet, which we have predicted, to have these sorts of signatures. So we think it is possible that this planet may host life, but we also want to remain very cautious because these are very initial observations and the level of evidence is only at a 95% confidence level or so. But in science, you want to be a lot more confident than that. A lot more observations. So we need to continue the same observations, but a lot more times. So that increases the signal that we are seeing. Yeah, and then eventually, I think we will get to a level where we would be confident. And by that I mean, you want the chance. When you say 95% confidence, there is a 5% chance that what you're seeing is some random signal that is not from the planet or from life. Right? We want to decrease that chance of a negative result to about less than a part in 100,000 or a part in a million.
Oh.
So you said 99.9999 and so on.
Yes.
And that is where we want to be. Yeah, first of all, if this is confirmed, if we confirm that, let's say, dimethyl sulfide is in this planet. So DMS or dimethyl sulfide is a molecule that's produced predominantly by life here on Earth. It's produced mostly by marine microorganisms like phytoplankton. So this is why for decades people have argued that this would be a good biosignature to look for in other planets because you don't have that many other ways to make it without life, right? So because we are talking about that molecule now, that has huge implications. If we actually can confirm that molecule on this planet, and then if we can confirm that only life is producing that, no other abiotic mechanism, then that is a huge deal.
Yeah.
In the sense that will for the first time answer this age-old question, are we alone in the universe, right? So that is the ramification and all the ramifications that comes with finding life out there. Yeah, so the word Hycean comes from, it's a portmanteau. It's a combination of two words, hydrogen and ocean. So this word we coined because we were trying to represent a planet that is covered in ocean. It has an ocean-covered surface under a thin hydrogen-rich atmosphere. So you have a hydrogen atmosphere and an ocean surface, and that is a unique combination. We don't have such planets in the solar system. So those two words together we put together to coin the word Hycean. So traditionally, when people talk about search for life elsewhere, the idea has always been to look mostly to look for Earth-like planets and biosignatures. But if you ask, how prepared are we to look at Earth twins or find life on Earth twins? That's a 20-year future. So in 20 years, we may have that capability to do that. But now, because of this new class of planets, we have demonstrated that those are actually observable with current facilities with the James Webb Space Telescope. And that's the big deal. We have brought that 20-year future to now, right? So if we can actually, and we are already finding signatures, right? Those are very tentative signatures. But if we can demonstrate that these signatures are robust and they're coming from life, that, brings that whole future to the present. It's very easy to think of a very human experience to think of the universe as a physical universe, right? So we have the stars, galaxies. We are amazed by them. We are inspired by them, but they're all physical objects, physical celestial objects. That's very different from, let's say, if you look at a forest or an ocean, which is a living entity, right? So you get that feeling of this is us, this is Earth, this is a living ecosystem, and that's an inanimate universe out there, a physical universe. We are excited and inspired by the physical laws, but it's a slightly different from our ecosystem that we have here. So there is that natural instinct in your psyche when you look at a sky where it is grand, but it's still a physical sky.
Yes.
Now, if you find life elsewhere, it changes that dynamic. So that is the realm where you'd look at a sky and a planet where there is life on it in the future, if that is the case.
Yes.
And then you would be seeing at the cosmos not very different from how you would see an ocean, right? You would see the sky with objects on which there is life.
Yeah.
And suddenly the human experience expands from just being restricted to Earth to being expanded across the cosmos. So you become that cosmic entity, life, right? So that reality of a living sky is one where we become part of a living universe. So to me, that's a very real shift in the psychology of our species.
So we realize we are just one tiny.
Exactly. So far from being alone, we would realize even if you find one planet robustly established, where it's robustly established that it has life, that by the sheer numbers would mean that there should be many more such planets in the sky. So just from answering the question, are we alone in the universe, you go into reality where you're an integral part of a cosmic entity. We're only seeing tentative signs of it. By that, I mean maximum for 95% confidence that the molecule is there, but that still leaves around 5% chance that it could be some fluke that we don't understand, right? Or some other molecule or something. And we want to be cautiously optimistic. As exciting as this is, it's a big claim. If it is true that we have found DMS, and if it is true that it's coming purely from life, that's a game changer. If there is life, it's a huge advancement in science. That basically answers the age-old question, are we alone in the universe? So for the magnitude of that question, you want to be very, very careful for the level of claim. This 2 sigma or 95% confidence is not good enough to make that claim, but it is very good to a good place to start.
I see.
Because the alternative was that we have never ever had any chance of finding life on an Earth-like planet around a Sun-like star at all with JWST. But the reason we're able to even do this is because of these properties of this planet that made it very conducive to observations. So when we are detecting it or finding it at a 95% confidence or so, it is a lot of excitement that this is the beginning, but the caution is coming from the fact that this is nowhere near the end and we have a long road to go to make it very, very robust as a signal. So this opens a whole new era in our search for life, because this says for the first time that we in principle have the capacity to conduct this search, and we are seeing the first signals. Whether those signals are real or not is where extreme caution is necessary.
Yes.
So we want to try to disprove the signal over and over again and see if we can explain it in any other way. So that was in April, and a number of papers have come out in the community providing alternate views of how they can explain it, and we have followed up on those as well. So there is a, for example, there was a study came. They said we had originally looked at 20 molecules, searched for 20 molecules, and we have found that DMS or DMDS or both of those are biosignatures, are the best explanation to the data we have. There was another study that came and said, but you may not have searched for enough molecules. You may not have looked hard enough. There could be other molecules that you didn't consider that could also explain the data. So they said we look for 90 molecules, basically all hydrocarbons on Earth for which there is cross-section chemical data that they can search for. And they said that there are 5 to 6 other molecules that could also explain it. So we said, that's a fair enough. That's a good argument. So let's go further. Why stop at 90? Right? Why choose just hydrocarbons? Look at every single molecule on Earth for which there is chemical data and do a robust search. And we did. So we looked at 650 molecules. That's the largest retrieval exercise ever conducted in the history of the field. And we did that just last year.
Oh, after this.
After the counter argument. And then we found that the previous study had only looked at mid-infrared data, whereas we had data from both near-infrared and mid-infrared. Right. So we looked at 650 molecules using all the available data and found that only 3 molecules rose to a level of significance that is needed to even make a tentative claim of a hint, and DMS was one of them.
Oh, again.
Yeah, again. And 2 other molecules are both molecules that are produced also by life on Earth, most of the time technological experiments. So these are molecules like methylacrylonitrile, which is an industrial molecule, right? So however you cut it, you need like a complex molecule to explain the little feature that we are seeing. Right?
Correct.
So these are the kinds of debates that are going in the field, and we are very comfortable engaging with any level of questioning, and because most of the time we ourselves are trying to find alternate explanations. So if someone else gives us a good counterpoint, we are more than happy to take it on board, because at the end of the day, you want to know the truth.
The James Webb Space Telescope, or JWST, is the largest telescope in space humanity has ever built. This is leading to major advancements across astronomy, but more specifically in the study of exoplanetary atmospheres. For example, this is the telescope that has been used to make the first detections of carbon-bearing molecules, methane and carbon dioxide, in the atmosphere of this planet K218b, which is 2.5 times larger than the Earth, but has temperatures roughly similar to what we see here on Earth. And so we think this planet might be habitable. And there are several other such observations happening across exoplanetary science, and these are leading to major breakthroughs in our understanding of planets and their atmospheres and planetary systems around stars beyond the solar system.
I mean, I don't think there is any particular contradiction there in my personal view, because all religions have their own definitions, perspectives about God, and there is an argument to be made that from a religious point of view, even though I'm not a scholar, I'm not a religious scholar on various religions and so on, but I can imagine a religious point of view of God being the ultimate entity in the universe from which all sources arise and go back to. So whatever we find in the universe is part of that same reality. So I don't see any particular contradiction if the definition of God encompasses the entire grandeur that is the universe. Purely my practical experience that for the longest time, the kinds of problems I work on are so much at the cutting edge of science that much of my need to engage with science is naturally satisfied. And I typically work at the very cutting edge of things, be it theoretical or observational, coming up with new concepts, new ways of doing things, and in astrophysics more specifically. So that to me is like much more than what I can get out of a science fiction narrative. I have nothing against science fiction, of course, but I don't have the inherent need to look at science fiction for that inspiration. My own science is often borderline strange and very cutting edge.
Yes.
And practical is that for everything I do, there are observational implications. So my science fiction turns into science very quickly. India is growing at a phenomenal pace in this sector, general space, but also space sciences and astrophysics and so on. So I think the future is super bright, especially for the young people. ISRO has more and more been involved in space missions for astrophysics, right? So there was AstroSat, and there are new missions being planned to study the solar system, to study astronomical phenomena, including exoplanet science. So there are new missions. ISRO is always thinking of encouraging new ideas. So I can see those coming to fruition in the not too distant future. But there are also, not just from space, from ground also, there are lots of ground-based efforts with ground-based telescopes that India is involved in. So I think India is going to play a major role in the future of not just astronomy in general, but also specifically exoplanet science, which is what we are talking about here. No, because of the kinds of facilities that are coming up and that are being planned, and knowing what is out there available around the world, and these facilities are on par with some of the best facilities that are available currently. Even in exoplanet science itself, there is a lot of work happening here in India on various levels, on planet formation, on even exoplanet atmospheres. There are teams that are doing it.
Yeah.
It is growing very quickly. So over the last decade, if you track India's progress of the Indian science community in these areas, it's enormous. There's a lot of progress that has been made, and a lot of good people are working here that are at global standards. So I don't see India as just another player in the game. I think India is quickly rising to the top of the game, both in terms of facilities that they have access to and their international participations with. I mean, breakthroughs are still in very early phase. They have capabilities for exoplanet detection, for example, but now they also have capabilities in atmospheric characterization, which is understanding these atmospheric observations. These will grow slowly. The community currently, as right now, is doing good work in the capacity building phase. So there are lots of facilities coming up and a lot of good people working here, but it will be very quickly into a whole different regime at the forefront of the field. So right now there are various groups around the country doing exoplanet science. So there is lots of scope for students to do like master's studies and graduate studies in those areas. But that is the right place to start, especially for students. And then, once you have graduate studies, there are the academic route one can take, but there are also non-academic scientist positions, and ISRO is also a good place for many people if they want to work more on the instrumentation and mission side of things. But there are also other labs around the country which do instrumentation. So there is a lot of scope across these areas. If we found life, it will be a remarkable paradigm shift to the field, but that is not the goal of the science. The goal of the science is to find what is out there, whether it's life or not life.
Yes. To know for sure.
To know for sure, whatever it is. So our current conclusion is that we are either finding some evidence of life, or we are finding some evidence for another complex chemical process that has no precedent here in the solar system.
That we are not aware of.
That we are not aware of. So either way is huge breakthrough.
Yes.
Observationally. So that's the realm we are in.